So, hello everyone. In this video, we will be discussing integrals of logarithmic, exponential, trigonometric, and hyperbolic functions. So, as I recall, let u be a differentiable function of x with a greater than 0 and a not equal to 1. So, these are the readily available integrals kapag nakakita kayo ng ganitong form sa integrand. So, integral of 1 over u du, integral of e raised to u du, and integral of a raised to u du. For the inverse trigonometric functions, let a be greater than 0. So, ito rin yung mga readily available integrals kapag nakita nyo itong forms na to. So, as a tip lang, madali nyo madidistinguish yung difference or kung alin yung sine inverse, tangent inverse, and secant inverse by looking at the denominators of these forms. So for hyperbolic functions, ito naman yung readily available integrals kapag nakita nyo yung ganitong forms. So kung napapansin nyo, medyo similar to sa trigonometric functions. So sa integrals of the trigonometric functions. Pero may difference sila sa signs, which you can notice hyperbolic sine and hyperbolic cosine. So reminder, when solving these kinds of integrals, it is essential to recognize the form of the integrand and deduce accordingly. And together with an efficient selection of a suitable u, this speeds up the process of integration. So yung sinasabi lang ng reminder na to ay i-analyze nyo muna yung integrand if may form na pwede nyong palabasin or pwede nyong i-manipulate yung integrand para makuha yung ganitong form like ganitong mga forms sa trigonometric functions or hyperbolic functions para hindi na tedious yung calculation process. And together with an efficient selection of a suitable u. So ito ay applicable na since LA1 nyo. So, mas efficient yung solution or yung process kapag mas maganda or efficient din yung nakuha nyo yung u. So, it saves time and effort. So, these are the problems. For problem 1, given tayo ng integral of the quantity x squared plus x plus 1 multiplied by 2x plus 1 all over x squared multiplied by x squared plus 2x plus 1 dx. So we start by expressing this expression as x plus 1 squared so that the integral now becomes this. Then simplifying the denominator, we get the quantity x squared plus x raised to 2. So as a continuation, let u be equal to x squared plus x, then du now becomes the quantity 2x plus 1 dx. So substituting u and du to the integrand, we get the integral of u plus 1 all over u squared du. So separating the numerator and expressing 1 over u squared as u raised to negative 2, we get this integral. So, since itong mga forms na to ay may readily available integrals naman, we can express 1 over u as ln absolute value of u and u raised to negative 2 as u raised to negative 2 plus 1 all over negative 2 plus 1 plus an arbitrary constant c. Simplifying further, we now get ln absolute value of u minus 1 over u plus c. Then substituting the value of u so that the answer would be in terms of x, we now get the ln absolute value of x squared plus x minus 1 all over x squared plus x plus c. For problem 2, we are given integral of x all over the square root of negative x squared plus 4x minus 3 dx. We rewrite the integral as follows. So, rewrite niya lang yung nasa loob ng square root as -3 minus quantity x squared minus 4x. So completing the square, at so yung pag-complete lang na square ay for this example I divide -4 by 2 and square the value. So we obtain this integrand. Simplifying further, we get the integral of x all over the square root of 1 minus quantity x minus 2 squared dx. From this, we let u be equal to x minus 2, which gives du is equal to dx. So substituting u and du, and noting that u plus 2 is equal to x, we have the integral of u plus 2 all over the square root of 1 minus u squared du. Splitting the integral, we obtain these integrals so that mas madali nating makukuha yung integral ng 2 all over square root of 1 minus u squared. So this is equivalent or equal to 2 sine inverse u plus plus an arbitrary constant c1. So for the integral of u all over square root of 1 minus u squared du, we let another constant v be equal to 1 minus u squared, so that dv is equal to -2u du. So the integral now becomes -1/2 integral of -2u all over square root of 1 minus u squared du. So rewriting the integrand, we get -1/2 integral of v raised to -1/2 dv. So getting the integral, we now have, and simplifying, we now have negative v raised to 1/2 plus an arbitrary constant c2. Then combining the two integrals, we get negative square root of 1 minus u squared plus c2 plus 2 sine inverse u plus c1. Then expressing everything in terms of x, we now get the final answer to be negative square root of 1 minus quantity x minus 2 squared plus 2 sine inverse quantity x minus 2 plus an arbitrary constant c. So since both c1 and c2 are arbitrary constants, pwede nyo gamitin yung c as the arbitrary constant for the final answer. For problem 3, we are given an integral of hyperbolic sine x plus hyperbolic cosine x all over hyperbolic cosine squared quantity e raised to x dx. At first, no suitable u can be found from as the argument of the numerator differs with that of the denominator. So yung argument ay for the numerator ay x, then sa denominator naman ay e raised to x. However, we can recall na yung identities, yung following identities for hyperbolic sine x and hyperbolic cosine x can be written as these two equations. So this implies that hyperbolic sine x plus hyperbolic cosine x is equal to e raised to x. So ito yung justification to show that the sum is equal to e raised to x. So the integral now becomes the integral of e raised to x all over hyperbolic cosine squared quantity e raised to x dx. So katulad lang sa trigonometric identities, we can rewrite 1 all over hyperbolic cosine squared e raised to x as hyperbolic secant squared e raised to x. So ito na yung magiging form ng integral natin. Then, letting u be equal to e raised to x, we get du be equal to e raised to x dx, which gives us this integral. Then, using the readily available integral with this from this form, we get the hyperbolic tangent u plus c plus an arbitrary constant c. So substituting the value of u, we get the final answer to be hyperbolic tangent e raised to x plus c. So that ends our lecture for this topics.